Hello everybody and welcome back. What we're going to do for this slide here is we're going to answer question number 5, just like we've been doing last couple questions there. In this case, what we do is we have to find the area. Now, the area, if you recall, that is the result from doing some multiplying between the length and the width. Multiplying. So what are we doing now with the challenge or with the expressions we have is we're going to be multiplying polynomials. Multiplying polynomials together. And we had a special word for that, and that was called distribution. So we're going to use that process in order to do the calculations for the area that's needed. And as a reminder, our work is going to look something like that, or perhaps something like this, then something like that, if you remember the lessons from before. Okay. Useful looking eyebrows. So we'll get started on the first one. The first one. That is the first. I guess it's a rectangle. It's there. Hopefully you can see it. If not, I'll help you out here. We got 3x along this side, and then 2x plus 5 on that side like that. And the goal is to figure all that in there. Right? How much space is contained, or how much content is inside. So, for a rectangle, length times the width. So that's what we're going to do. Now, to be professional, you actually want to start with the formula. And then, as I said, have it all lined up beautifully. Then you can be proud of your, increase your chance of getting the answer right just because it's neat and organized. And then you can be proud of your work when you're done. All right, so as promised, here we're going to do, the eyebrow. We have the 3x on the outside. That has to multiply by the 2x on the inside, and then with the 5. So that's going to look like this. That 3x is going to multiply with that, and then it's going to multiply with that. So doing the first one first, we have 3 times 2, which is 6. And now we got our exponent rules coming up. We have x times x, so that gives x squared. For the next term, 3x times a plus 5, that gives a plus 15x like that. Taking a look, we have x squared, we have x. Those are different things. They do not combine together. So, what we can say, beautiful, all lined up. What we can say is that this expression here, since it comes from multiplying the length with the width, this expression here in fact represents the area inside of this rectangle. Done. So let's take a look now at the last example. Rectangle again, but the sides are looking just a little different. How are they different? Well, they both have 2 terms in them. Remember, I'm not sure if it's remember, but binomial is the word when there are two terms. So just like the 4x minus 1, that's a binomial, and the 6x plus 9 there, that's a binomial. All right, well, let's do this. Yeah, officially you should draw the picture, or use the picture. I'm gonna have to draw it because I could draw on my computer screen, but it wouldn't really work. All right, so that side's 4x minus 1. This side's 6x plus 9. Ooh, minus 1. This area on the inside is what we're looking for. So the area, like before, because it's a rectangle, is the length times the width. Okay. So we have the length here and the width there. All right, so we can write it down and do the correct careful algebra to get to the end. Okay, so A is equal to length times the width there. The length, 6x plus 9. Now, what's special is that, just like in the picture there, it's in a set of brackets, because those pieces are actually belonging together. Without the brackets, they're starting to go their own separate ways. So the bracket shows that they're connected. One thing. Same with the 4x minus 1. That goes in brackets for sure. All right? Otherwise, it's starting to separate. So, this expression now represents the area, because it comes from the length multiplied by the width. Length of 6x plus 9 with the 4x minus 1. But to get the gravy, to do well in life, you have to be able to multiply this out. And so that's going to involve now two eyebrows, or rainbows, I guess, as we've been saying here. So you got to multiply the 6x by the 4x. Goes like that. And then the 6x times that last term. And then we repeat the same with the plus 9. But we'll do that in a moment, just to keep this looking good. So the area, we can leave A up there, equals, do the multiplying, 6 times 4, the first terms, that's 24. X times x, using exponents, gives x squared. Then the next is 6x times negative 1, that's negative 6x, because a plus times a negative creates a negative. Right on, the next two terms. Yeah, underneath, a little messy, but that's how it goes. One of those, one of those. So we got 9 times 4x, that's going to be plus 36x. 9 times the last thing, negative 1, is negative 9. Beautiful. Beautiful, but not finished. Okay, we got to collect like terms whenever you see them. And then you have to write it in order as well. But it's already in order. Squared, 1, number. Okay, so let's finish this up. The result from multiplying the length and the width is this polynomial. And when you collect like terms to finish it up, it looks like this. 24x squared. Why? Because there's no other x squared. It's just there. So just write it down. Here, got to do a little bit of work. We have an x and an x. Those two are going to combine together. Careful with your integers. They're opposites. Going to subtract. The big one's going to win. Okay, so you get 30x like that. And then lastly, this is a number on its own, no variables there. And that's the only one. Nothing else to combine with, no other like terms. There's nothing like it. Okay, so you just copy it down there. So what we've now done is from our picture, we were able to calculate using a length with an expression, a width with an expression, calculate what the area is, calculate a polynomial equation, how you can think of it, but polynomial here, and simplify it with like terms to get this answer here at the end, which is the one that we're going for. All right, good people. Well, there are quite a few examples there for you. Show you how to use the polynomial rules and operations that we worked with, how exponents can sneak in when solving these and simplifying these expressions. Okay, so I will leave you to the questions that are now available for you. I wish you luck and enjoyment when you as you work your way through them. Thank you for stopping by, and I'll see you next day.